If you have been using Kiro for a while, you have probably set up MCP servers and written steering files. But every time you start a new project or onboard a teammate, you are redoing the setup from scratch. In this video, we'll look at Kiro Powers, a way to package all of that into a single installable unit. Let's understand the situation with an example of you and your peer working on a same project using Kiro. You configure two MCP servers and return 4 steering files. Everything works great for you. Now your peer starts working on the same project on his or her computer. He or she configures just one MCP server and are missing 2 of the steering files that you had, the deployment guide and custom tool pattern steering file. Even the included steering files may be written very differently. What does this mean? Both you and your peer are working on the same project but with different setups. Their agent generates different code than yours, and when they hit a deployment issue, they don't have the steering file you wrote for guidance. When they build a custom tool, they are not getting any guidance on design patterns that you had in your steering file. A lot of information is locked in your computer. The knowledge exists, just not available for everyone to use. So how do we go from individual configuration to a shared setup? You have written steering files. You also have configured MCP servers for yourself. However, that's your steering and your MCP configuration, defined by you for you. But what if all of that could come pre-packaged? That's what Kiro Powers gives you. When you install a Kiro Power, you get many parts that we need for developing using Kiro. Your steering files, MCP configuration, and hooks, all bundled together. Now your peer installs the same power and gets the exact same setup. No manual configuration required, no missing pieces. Now you might be thinking, if a power bundles steering files and MCP servers, does that mean all of that loads into context on every request? No, it doesn't. Kiro Powers are designed to load on demand, not upfront. We'll see exactly how that works in this video. Now that you see the value, let's look at what a power actually is. A power has up to 4 parts. First part is power.md. This is where you put the overview, usage guide, and examples for whatever technology or workflow your power covers. The front matter of this file also includes keywords like strands or bedrock that tell Kiro when to proactively activate this power based on keywords in your prompt. This is what gets loaded into the agent's context when the power is activated. This tells Kiro agent what this power is all about. The second part is MCP servers, and this one is optional. The important thing here is that these only enter context when you activate the power, not at startup like ROM MCP servers. Third, you have the steering files, which are also optional. These are your workflow guides and conventions, things like how to get started, how to deploy, or how to structure your code. The agent can read these on demand when it needs guidance for a specific task. And the fourth and final part is hooks, also optional. These are event-driven automation rules that come bundled with the power, so when your team installs it, they get the same automated workflows too. Now, not every power needs all 4 parts. A documentation-only power might just have power.md and some steering files. A tool-heavy power, on the other hand, might focus on MCP servers with minimum docs. You build what makes sense for your use case. Now let's talk about why this on-demand loading matters. On the left, you see what happens with raw MCP servers. Every tool definition from every server gets loaded into every single request. You got 5 servers here with a total of 51 tools, and that adds up to tens of thousands of tokens. That's a lot of your context window being consumed before you even get to your actual conversation or your code or the agent's reasoning. The remaining space for reasoning gets squeezed. On the right, you see what happens with powers. Only the tools from activated power enter context. In this case, power B is the only one you need, so it loads its tool definitions along with power.md documentation and steering file list. The other 4 powers, They cost you absolutely nothing, zero tokens. So you go from tens of thousands to few thousand tokens. And all that freed up space goes back to what actually matters: your code, your conversation history, and the agent's ability to reason through complex problems. So let's walk through how powers actually work behind the scenes, starting with what happens after you install a power. You install powers through powers panel on the command palette, but once they are installed, Kiro automatically knows what's available. It has a power metadata, the name, description, keywords, and which MCP server each power includes. But here's the key thing: nothing is loaded into context yet. The tools stay completely dormant. This is a fundamental difference between raw MCP servers, which load all the tool definitions at startup into every single conversation, and powers. With powers, they just sit there quietly until you actually need them. Now, here's where it gets interesting. You send a prompt, something like "Help me build an agent with Strands SDK." Kiro passes that along to the agent with full context. The agent looks at your prompt and notices that the word strands matches a keyword from one of the installed powers. So it calls activate on that power, and back comes everything the agent needs: the power.md documentation, full tool schemas, and steering files. At this point, the agent has a complete picture. It understands tools it has access to and guidance on tasks. All of that loaded just in time because you mentioned the right keyword, not because it was sitting in context from the start. Continuing from where you left off, the power is activated and the agent now has the tool schemas in context. So the agent starts reasoning over your prompt along with activated power tools. When it decides it needs to search the strands documentation, it calls the tool through the installed power. The power routes that call to the MCP server, which does the actual work and returns a result. The agent gets the tool result back and evaluates whether it has enough to respond or needs to make another call. This is the same agent loop you would see with any tool: reason, call, evaluate, continue, or respond. The only difference, however, is that these tools are loaded on demand when the power was activated, not sitting in context from the moment you open Kiro. The agent has another option after activation besides calling tools, and that's reading a steering file. Remember, when the activated response came back, it included a list of steering file names. So the agent looks at your prompt, looks at that list, and thinks, I need to build a strands agent, and getting started.md looks like exactly what I need. It calls read steering, and back comes a markdown with step-by-step instructions, code patterns, and best practices, all written by the power author. The agent then follows that guide to generate your code. And just like before, it evaluates whether it's done or needs to continue. Maybe it reads another steering file or calls a tool or just responds back. Both calling a tool and reading a steering file are options within the same agent loop. The agent picks whichever makes sense for what you asked it to do. So that's how powers work from the user's perspective. Now let's flip to the other side. When would you actually want to build your own Kiro power? Now, if your team uses an internal framework or SDK that the community does not have a power for, that's a great reason to build one. Or if you want everybody on your team to have the same setup across projects, same steering, same tools, same conventions, a power gives you that consistency. Or if you want an agent to follow your team's specific patterns instead of guessing, packaging those patterns into a power means that agent actually reads and follows them. Instead of a wiki page that nobody reads, you get an installable unit that agent uses every time. Let me show how to build one. So let me show you the full cycle. I'm going to start by installing the build a power from the panel. Yes, there is a power for building powers. Now I'll click try power and it opens up a chat session where it asks me what kind of a power I want to build. So I describe what I need. And Kiro goes ahead and builds it for me. Let's look at what it created. You see the complete power directory right here, and with all four parts we talked about earlier. Let me open the steering files first. Kiro Powers Builder Power created three for us. You can review and update them as needed. Now let me show you the MCP configuration file. This again can be updated as needed. And finally, power.md. This is the documentation with all keywords like strands, agents, bedrock tools. This is what agent reads when the power activates. Now I need to install this as an actual power. I click add custom power, choose import from the folder, navigate to the directory and select it. And there it is, installed in my powers panel. Strands Agent SDK with our keywords, our MCP server configuration, our steering files, all ready to go. Now here's the thing, this whole folder can go into a Git repo. Your teammate can pick it up from the repo and they get the exact same setup you have. Same steering files, same tools, same conventions. Now let's put our custom power to work. I asked Kiro to build me a strands agent with a custom weather tool and deploy it to agent core. It would pick up my steering file, but more importantly, it would activate our custom power because it spotted the keyword match on strands and bedrock. It reads the power steering files and it says, now have all the context I need. Let me build this out for you. And look at that, your agent was created. The knowledge we packed into the power guided the code generation task. But here's the really interesting part. I'm going to ask for something completely unrelated. And just simple Python script for a print of hello world. No strands, no bedrock, no agent keywords anywhere in the prompt. And what happened? Kiro just created a file. One change was accepted. No power activation, no steering red. The power stayed completely dormant. That's the on-demand loading in action. Power only shows up when you actually need them. Thanks for watching. If you have questions or want to learn more, check out Kiro's documentation. Happy building!